Okay, scholars, so we are moving on to Unit 1, Lesson 3, Session 2. We are still working with sequence of transformations, so we're doing more than one transformation on an image. Our objective is to perform those transformations and to understand that one figure is congruent to another if you can get it to line up with the first after doing all these transformations. You're going to need your workbook, pencil, graph paper if you've got it, and some type of straight edge. If you're doing this lesson on your own, it will take about 35 to 45 minutes. So try it. So we're going to go through this problem and figure out what is it asking us to do and what information do we need in order to do it. So we have two people. We have Kimani. We have Kimani and we have Jake. They each perform the same two transformations on figure T, but not in the same order, okay? So Kimani reflects across the y-axis first, then translate 4 units to the left. Jake does it in the opposite order. So Jake translates first, 4 units to the left, then reflects over the y-axis. Will both sequences map figure T onto the same final image? So what they mean is if I take this figure here and I reflect it across the y-axis, so from quadrant 4, reflecting it over to quadrant 2, and then if I translate it to the left, is it going to be in the same place as if I were to translate it first and then reflect? Okay, so we're going to work through that and see if figure T ends up in the same place, even if you do the transformations in a different order. Okay, so if you reflect first, which is Kimani's way, it's 1, 2, 3, 4, 5 spaces from the y-axis. So we go 1, 2, 3, 4, 5. So, excuse me, this first dashed figure, this is where it is after the first reflection. Then we translate 4 spaces to the left to end up with the figure being over here for the final location. If we do it Jake's way, and first we translate 4 spaces, so 1, 2, 3, 4, we end up here at the dashed figure. Then we're going to reflect it over the y-axis, and we end up with this being our final shape. So if you do the sequences in a different order, will the shapes map to the same place? The answer is no. This is way over here at -10, and this one is just at about -3. So no, they're not in the same place. The shapes are still congruent, it's still the same size, it's still the same shape, but they are in different locations. Another way to think about it is to look at all of your ordered pairs. So if you follow Kimani's sequence, which is in this first table, we have the original figure. After it's reflected, because we reflected across y, all of our x's became their opposites, so now all the x's are negative. The y's remained the same. Then we translated 4 units left, so we subtracted 4 from all of our x's to end up with our final ordered pairs here. Doing Jake's sequence, first we're going to translate by 4, so first we subtract 4 from all of our x values. Then we reflect across y, so all of our x values then become their opposite. So now we end up here at completely different order pairs than Kimani's sequence. So they're in completely different locations because we did the sequences in a different order. So the order does matter in terms of location, but not in terms of size and shape. They're still congruent, they're just in different locations. So connect it. You should pause here answer these two questions in your own words, and then come back and see how you did. Okay, so did both sequences map figure T onto the same final image? No. The images are in different locations. So how do picture it and model it show this? So we already explained it. Picture it when we actually saw the graphs, you could see that Kimani's image was further to the left than Jake's because she translated in the end. And model it, we were able to actually see that the ordered pairs for the final image are different. So that's how we know they don't map onto each other, meaning they're not in the exact same place. How do you know that both final images are congruent? Because rigid transformations preserve the size and shape. All we did was reflect and translate. So we did not make the shape bigger or smaller. We didn't make any other change. So since we only performed rigid transformations, the shapes are still the same size and the same shape, which means they are still congruent. You're going to do a couple of practice problems now, and then you'll be ready for your exit ticket. So you'll head over to your Google Doc, make sure you're using your notes, refer back to the video if you need to, and you are ready to finish this lesson.